hyperbolas, and there's a mistake, and I didn't fix it from last year, so the mistake's still here. This second one is not right, so you just mark out the second one. Here's what the second one should be: y minus k squared, or I guess y minus k squared all over a squared minus x minus h squared over b squared equals 1. Okay. So what matters in, let's back up. What mattered, how did you tell what the orientation was with an ellipse? How did you know if it was left and right versus up and down? Yeah, whichever number was bigger controlled whether it was left and right or up and down. Yes. What matters more for hyperbolas is which one is first. And so that's why with ellipses we always said A was the bigger one. Here we say A is always first. And so if X is first, then that means this is a left and right hyperbola, because X is the left and right variable. If Y is first, then it's an up and down hyperbola, because Y is the up and down variable. And even more so than with the ellipse, exactly who's A and who's B kind of doesn't matter. If it's under X, go that many in X. If it's under Y, go that many in Y. So let's jump in and graph one of these. Finding the center is the same. So Jake, what do you think the center is for that first one? Good. -1, 3. Look at this, our very first hyperbola, and I'm already pulling popsicle sticks. Luke, what do you think we do with that 9?
Well, it's not first, so bet you make it a 3.
Okay, and then what do I do with the 3? You're right.
Well, does it matter? Do you still go left and right with it?
Mm-hmm. It's under X, so I'll go left and right 3. Cecilia, what do you think we do with the 25? Good, up and down 5. Okay, so here's the big difference, though, in the equations is the minus sign, right? Because the minus sign is what makes it a hyperbola rather than an ellipse. So that whether that sign is minus or plus is pretty important. All right, here's where the how to graph it takes a turn from what we did with the ellipses. Because the ellipses we just about be done, right? You sketch in the oval and you're done. Hyperbolas, there's a lot, it's a little more complicated. So the first thing we'll do, or well, after we've done the A's and B stuff, is draw in a box using those 4 points. Draw in the box. Next, we're going to draw the diagonals of the box. So use a straight edge, an ID, a popsicle stick, whatever. I'm going to use dash lines because those are going to become asymptotes for us. The diagonals of the box. Now we're ready to sketch in the U's, the actual hyperbola. Let's see, is this one left and right or up and down? Uh-oh. Why is it left and right? Because x comes first, okay? Well, the y is bigger, but we don't care about who's bigger for hyperbola. Yeah, if this was an ellipse, if we'd have changed that to a plus sign, we'd had a much easier problem to do. But it's a minus sign, so it's a hyperbola, so what comes first matters. So it's a left and right hyperbola. So it's going to be a very wide hyperbola. The 2 points are the vertices. In fact, that's in the box right there. The vertices of the hyperbola are the points on the box that are on the graph. So there's only 2 vertices. So go through the vertices and then head toward the asymptotes. So I don't know. I think these are fun to graph. You end up with like the Spider-Man web thing for your picture. Next one. Maybe to make sure we get this right, Joseph, let me ask you big picture. On B, is this going to be an up and down hyperbola or a left and right hyperbola?
Up and down.
And how did you know that?
Because y is first.
Y is first, so it's up and down. And so some students, I'll even see this on tests and stuff, I'll see a little up and down hyperbola right there. Like they're sort of making a note to themselves that regardless of the details, I better finish with an up and down hyperbola. Landry, you've got the trickiest question of the day. No worries. What's the center of that hyperbola? Ah, you fell for it. It's not 4, -1. Do you see why? So you got to be careful. We're so used to x being first that you just kind of read them off in order, and that's the mistake. Like looking, if you take time, you see what happens, but if you just look quickly, it's like, oh, 4, -1. Whoops, wait a minute. The x got to come first, so -1, 4. It's okay. Make your mistakes on regular days, not on test day. Ben, what do you think we do with that 16?
Square root it and go 4 up and down.
Good. 4 up and down because it was under the y. Gregory, how about the 36? What do we do with that?
Square root it and 6 left and 6 right.
Good. Left and right 6. All right, it's only our second one. What do we do next? Anybody?
Make the box.
Make the box. Well, Gregory did the asymptotes. You're a step ahead. You already made the box. Yeah. But yeah, because you couldn't make the x's without having the box. So make the box and then the x's. And this is where some people get creative and make their box one color and the x a different color and then the hyperbola a different color. So make the box and then grab a straight edge and line it up through all 3 of those points. The 2 corners in the center. Okay, we're close. Cole, last thing. Draw them up and down or left and right? Up and down, because we said earlier, y comes first. This is going to be up and down. So this one's another really wide hyperbola. All right, I say we skip number 3, or part C, because it's the same stuff we've just been doing. What's the center for C, after I said we skip it? 0, 0. And is it left and right or up and down? Left and right. Okay, we could skip C. Number 2. Again, the vertices are the points. The vertices are what you think the vertices are, right? Like, you know what the vertice of a parabola is. It's the same thing. It's just the bottom of the curve, or the leftmost or rightmost point. So the vertices in 1A, and probably the easiest way to do it is to just read them off the graph rather than trying to, if you look in books, there's formulas about it's H plus A and K minus B, or just look at the graph. So that would be -4, 3. Is one of the vertices, and 2, 3 is the other vertice, the other vertex, I guess. For 1B, again, now you're just like reading points off a graph. So this is 7th, 8th grade stuff here. So 5, 4. And then it's a long way over there, -7, 4. And again, there are formulaic ways to find those based on the center and A and B, but it's not worth thinking about. It's just graph it and give the point. Number 4. Brandon, what's the center of that one? Good. Yes, sir. No.
Number 3 on the vertices.
Oh, yes.
Is it the dots on the side, or is it up and down?
Yes. Thank you. Yes. It's got to be the ones up and down because it's the up and down graph. Good catch. Thank you for paying attention.
I just didn't even answer because I thought I was tricky.
So, -1, 8 and -1, 0. Does that look better? Yes, thank you. Back to number 4. So the center is 6, -9. I don't, and I'm also just asked for the vertices. I'd kind of like to not graph the whole thing if I can avoid it. Is this thing left and right or up and down? Left and right. So again, maybe you can find the vertices without graphing it. I'm going to do at least a little rough sketch here. So there's my 6, -9. How am I going to find the vertices? Where are they going to be relative to my center? Good. Well, be careful, just 8 left and right. The 10 up and down would help make the box, but for the vertices, I just need the 8 left and right. So you can sketch them out, or you can think 8 left and right. This gets to what I said we would probably try to avoid, but we're going to do it anyway here. Which coordinate do I need to adjust if I'm going to go left and right? 8. The x one. So 6 plus 8 is 14. 6 minus 8 is -2. So you can kind of graph it, but you don't need to graph the whole thing if you're just asked for the vertices. Why don't you try number 5? Just be careful. So there's the center, 0, 11, 2 vertices because you're going up and down 9. It's up and down, so you're adjusting the y coordinate. Flip the page. Every hyperbola has 2 foci, just like every ellipse has 2 foci. The 2 foci lie outside the parabola as opposed to inside the ellipse. But for both of them, the graphs wrap around the foci, if that makes sense. It's the focus of the graph, so I don't want to say centered. They wrap around the focus, whether it's an ellipse where they're on the inside, but they're wrapping around the focus. Hyperbola, they're on the outside, but it's wrapping around the focus. So to me, I remember it this way. That way it's the same rule for both of them. Here's the definition. For an ellipse, it was the sum of the distances was constant. For a hyperbola, it's the difference of the distances. So this is a little bit harder to sketch out, but if you pick any point on the hyperbola, d1 minus d2 is a constant. Any point you pick, d1 minus d2 is a constant. You don't need to know that. That doesn't really... Yeah, it would be hard to write a test question if that's that anyway. To find the foci, use this equation. Uh-oh. So, yeah, I never know if this is good news or bad news, because it's good news because it's, hey, that's the one we recognize, right? That's the Pythagorean theorem, a squared plus b squared equals c squared. But bad news because what was the ellipse? A squared minus b squared. So you got to be careful. The ellipse has a minus there. The hyperbola has a plus. So the ellipse, the main equation has a plus in it, but c squared has a minus in it. For a hyperbola, it's backwards. The main equation has a minus, but c squared has a plus. So however you want to kind of keep that straight, you've got to be careful about c. If you get the plus and minus backwards, your foci will end up in the wrong place. So if you're paying attention, you'll catch that you made a mistake. If you use plus for an ellipse, your foci will end up outside the ellipse. If you use minus for a hyperbola, your foci will end up outside the hyperbola. So if you're graphing and you're really paying attention, you will catch your mistake. Number 5. Find the foci of the hyperbola with this equation. We're already out of popsicle sticks. Danny, is that left and right or up and down? Good. It's a left and right hyperbola. So that means my foci have to be left and right, because they're always on the main axis. For an ellipse, that's the longer axis. For hyperbola, it's whichever one comes first. So my foci will be left and right of whatever the center is. Speaking of the center, now that we went through everybody, we just have to throw them all back in the pile and start over. Lucky day, you get to get called on twice. So JD, what's the center of that hyperbola? Of number 5.
Negative 3, 1.
Wait. The center?
The
Yeah, you're right. I'm sorry. Negative 3, 1. You said that right. Negative 3, 1. If I want to get to the foci, Luke, which way do I need to go? Thank you.
Oh, you need to go left and you need to go right.
I need to go left and right to get to my foci. So which coordinate should I adjust to get there? The x. So I'm going to go left and right to get to my foci. Austin, Gifhorn, Austin. How many left and right am I going to go? Oh, wait, we don't know that yet. How do I figure out how many I go left and right? Do you know? Yeah, c squared equals a squared plus b squared. And kind of like with ellipses, it didn't really matter who was a and b as long as you did the big one minus the little one. Here it matters even less, right? Because if you switch a and b on this one, you're adding them. It doesn't matter. So c squared is 100. C equals 10. So I need to do plus and minus 10 from the center. So negative 3 plus 10 would be 7. Negative 3 minus 10 would be negative 13. So there's my two foci. Ava.
Are we going to do that thing that's like negative 3 plus or minus 10?
Yeah, absolutely. Yeah. Good question. So if you wanted to just write that as negative 3 plus or minus 10, comma 1, either one of those answers is acceptable, completely, equally acceptable. Not a preference at all. Because that's shorter, it's also sort of almost more descriptive of how to find the foci. You go left and right 10 from negative 3, 1. If you want the actual points, then you can write them out. So either one is fine. We can skip number 6, except that I want Audrey to tell me where the center of number 6 is.
Negative 8, 5.
Good. Number 7. Graph the hyperbola with that equation. Uh-oh, what's coming? Complete the square. With half it, square it, add it. So let's group our x stuff, group the y stuff, see what happens. Move that 64 out of the way. I'm just going to get a little bit trickier still on this one. Ava, what do you propose we factor out of the x stuff? The 9. So x squared plus 4x. Danny, what do you propose we factor out of the y stuff? Negative 4. We want to take out the negative 4. So now for the half it, square it, add it portion of the problem. Half it is 2. Square it, we get 4. So I write plus 4. But what did I really just add to the left-hand side? 36. And then we'll do the same thing for the y stuff. B over 2 is 4. Squared is 16. So I'll write plus 16. But what did I really just do to the left-hand side? yeah, I gotta account for that negative 4. So what do I need to do to the other side to keep things balanced here? Subtract 64. So that subtraction thing is what makes it hyperbola, and that's also what makes this completing the square just a half a step more difficult than the previous ones. So 9 times x plus 2 squared minus 4 times y plus 4 squared equals another nice one where the 64s cancel out and we're left with 36. Noah, what do I want to do next? I'm almost there, but not quite there. To make this look like I haven't done anything wrong, but it doesn't look like a hyperbola equation yet. What could I do to make it look like number 5 or number 6? Yes, because what will that do?
The right side one.
Yeah, so let's divide by 36 because it will make the right side 1. X plus 2 squared over 4 minus y plus 4 squared over 9 equals 1. So now we've got it looking the way we want it to look. So center at -2, -4. Maybe we'll get through everybody twice today. Cecilia, what do we do with that 4? Left and right, how many? 4 or 2? It's not 4. That's a squared. So a is 2. So left and right 2. Gregory, how about the 9? What do we do with that? And down 3. Kind of tempting to sketch in an ellipse there, but we know this was a minus sign, so this is a hyperbola. So what do I do next then? I can't make the circle thing. What's the next step? You remember? Make the box and then the diagonals. One more check before we sketch it in. Evan, is this left and right or up and down?
Left and right.
Left and right. Number 8. Find the vertices and foci of this hyperbola. Although something's a little bit different about this one than the last one. What's different and how do you propose we fix it? I don't even know if I'm asking the question right. I think I want to write the y stuff first since y squared is positive. So y squared minus 6y minus 4x squared plus 16x equals 11. So the y squared stuff is ready to go. The x squared stuff, or the x stuff, I need to factor out a -4. So we'll add 9 to both sides, because that didn't require any sort of adjustment. For the x stuff, half of b is -2. Square that, we get 4. So plus 4. But what did I really just do to the negative 16? So 20 minus 16 is 4. Pick on Noah one more time. Noah, what do you want to do next? Divide by 4. What do you want to do with this x stuff? Because the 4's cancel. So it wouldn't be wrong to write it like that. Just looks a little bit funny. What could you do to make it look more like a hyperbola? Put it over 1. But, I mean, it's not wrong like that, but it just feels like it doesn't look right. So I'm going to put it over 1. Okay, now the hard work's done, but we still got to finish this problem out here. Austin, what's the center? Good. Especially vulnerable on ones like this where we've done a whole lot of work, our brain's a little tired, we think we're near the end. Pay attention to who's x and y. Joseph, is this up and down or left and right?
Up and down.
Up and down. So, Cole, if I want to find the foci, which coordinate is going to get adjusted? The y coordinate. In fact, if we want to sort of take Ava's approach here, I know it's going to be 2, 3 plus or minus. Then I just got to figure out what the something is. So that doing it that way is not a bad approach because I can sort of set it up before I even figure out what c is. C squared. Let's see, a hyperbola. The main sign is subtract, so it's a squared plus b squared. I don't get a particularly nice number, but that's fine because I'm just going to write it as plus or minus the square root of 5. Alright, today's assignment is Worksheet 3 on the ellipse. And again, we really are done with the new information on...
Oh, that was the bell.
That is the bell. Oh, it's pep rally. So, we finished just in the nick of time. Enjoy homecoming.